Greetings, 8th graders. So it's kind of gloomy outside today, and I figured it'd be kind of fun for a rainy day project to put together a periodic table on my table. So here's our dining room table, and I laid out whatever elements I could find, just lying around the house, in an effort to explain to you guys a little bit about how the periodic table is put together and what these elements are. So starting over here in the textbook, and of course you don't have a hard copy of the textbook, but you have an online version of this. This is what the periodic table actually looks like. And I always thought that was kind of unusually organized because you have one element up here, and you go all the way across here, you got another element, and then you got two over here, then you got this big gap, and you got 6 more elements, and then you got 2, and then another big gap, and you got 6, and then you got 18, and then you got 18, and then you got a couple here, but then it jumps down over to there. So what is the deal with this periodic table and how it's all laid out? Well, let's start by talking about what atoms are made of and help you to identify how an atom becomes different when you add different things to it. So starting off with an atom. Atoms have protons, neutrons, and electrons. All right. And the electrons are the parts that go around the atom. That's what that little circle is right there. So an atom that has 1 proton is automatically going to be element number 1 on the periodic table. And element number 1 on the periodic table is hydrogen. Now, if I add another proton to this, and usually with every proton you add another electron. So an atom that has 2 protons is atomic number 2, and that's going to be helium right over here, atomic number 2. And then if I add another proton, which means I add another electron, and you're probably wondering why I'm not adding any more neutrons to it. Just neutrons can vary from atom to atom, and sometimes atoms have different numbers of neutrons, but we're just going to focus on the protons because that's the most important number on the atom because that gives you the atomic number. So 1, 2, 3 protons, and again atoms will usually have 1, 2, 3 electrons to balance out that positive charge. 3 protons will be atomic number 3, lithium. 4 protons, another electron there, become atomic number 4, beryllium, and so on and so forth. Every time you add another proton, you get a new element. Carbon is 6, nitrogen is 7, oxygen is 8. So every time you add a new proton, you get a new element. What's really cool is when you get down here to the periodic table, if it's got 79 protons, it's going to be gold. But if it has 80 protons, it's going to be mercury. And if you know anything about mercury, it's fairly common. It makes lots of compounds, but it's pretty toxic. And it's nasty stuff. You don't want to have that around. But gold is very valuable and very precious. If you take atoms of mercury and just knock off 1 proton from each of those atoms, you would turn mercury into gold. It would be cool if we could be able to do that on a mass scale. We can't do that right now, but it would be pretty awesome. So at any rate, that's how atoms form elements. So by adding more protons, you change the identity of the atom, or the element rather. But also by taking away protons, you can also change its identity. And that's where radioactivity comes into play, and that's something we'll talk about later. But right now, let's take a look at the elements on my periodic table. So here's what hydrogen looks like. It's a gas, you can't see it. And coincidentally, helium also looks like hydrogen. I got that from a helium container down in my basement for balloons for a birthday party. Now, I don't have all the elements here, obviously, but carbon has 6 protons. And this is what carbon looks like, just little chunks of coal right there. It's a model of a carbon atom. Remember that from the classroom. Nitrogen over here. Wow, nitrogen looks just like helium and hydrogen. Go figure. And this element makes up most of our atmosphere. Oxygen looks just like nitrogen. It makes up about 21% of our atmosphere. This is about 78%, 21%. That's 99% of our atmosphere is those 2 gases. Aluminum has 13 protons, and this is what aluminum looks like. You've seen aluminum foil before. This is about a dozen aluminum soda cans that were melted down in a foundry and just melted into that little ingot right there. Silicon, element number 14, looks like a metal, but it's got a unique property to it where it doesn't quite conduct electricity the same way as metals do. Plus the fact, even though it's nice and shiny, if I tried to pound this, it would actually be very brittle and kind of fall apart. So it's got a different property to it. It's what we call a metalloid. And I'll take you back to the periodic table and we can look at metalloids a little bit later on. Let's go through these. Sulfur, this is what a sulfur atom model would look like. With 16 protons. Iron, I don't have any iron that's natural from nature, but I got some iron rings right there and an iron nail. Copper, this is copper from nature, and some copper wire. Now notice that iron has 26 protons, copper is 29 protons. 3 more protons, you get a totally different element with different properties to it. Zinc has 1 more than copper, it's got 30 protons. And here's some zinc nuggets, and here's a penny. And remember we said pennies are made out of zinc, but they have a copper coating to it. I just scratched the copper coating off of that, so that's what a zinc penny looks like underneath that copper. Gallium, this was a very popular element mentioned earlier on. This is an element that actually melts. If I were to hold this in my hand for a long period of time, my body heat would actually melt it because the melting point of gallium is right around 82, 83 degrees Fahrenheit. So it's got a very low melting point. Cadmium, that's what this element is. It's kind of a heavy metal rod right there. It's used in nuclear reactors to slow down a nuclear reaction. Hopefully this rod did not come from a nuclear reactor. Indium, that's this element right here. It just looks like a little silver ingot, kind of heavy. Antimony is this element right there. That's a metal. Iodine is actually a purplish solid, but usually you can see it dissolved in a liquid and it turns on kind of a brownish amber color. And that's something you might have in your medicine cabinets at home. Gold, believe it or not, I actually have some gold here. I think we showed you that earlier in the school year. And there's some gold foil on this little wallet thing that I have right there. 79 protons. Lead, not nearly as valuable as gold, has 3 more protons to it. Here's a lead weight. And then bismuth, it's kind of a colorful metal right there. It's got 83 protons. So all those elements are spread throughout the periodic table. Now, if you take a look at the table, all those yellow elements that you see right there are all metals. Metals make up the majority of the periodic table. Almost everything on here is metals. Hydrogen you see right there is in green. It's not a metal, it's actually a gas. And same thing with helium, neon, argon, krypton, xenon, and radon, they're all gases. So everything in green is not a metal. In this case, there's a bunch of them that are gases. Now sulfur, that yellowish element that we saw earlier, is also not a gas, but it's not a metal either, so that's why it's colored in green. So the metals are all yellow, the non-metals are all green right here. There's iodine, and iodine's clearly not a metal, so it's in green. But the ones that are in purple right here, this is kind of cool. These are like the in-between the metals and the non-metals. These in-between elements that aren't quite metals and not quite non-metals are what we call metalloids. And that's where silicon comes into play. So silicon we showed earlier is this element right here. Now again, it looks like a metal, but if you were to hold it in your hands, you'd feel that it's not quite metallic, it's not super heavy. And if I were to try to smash this, I wouldn't be able to pound it flat like you can pound certain metals like gallium and indium flat. And I also can't shape it into a wire like this or a rod, or pound it flat like aluminum. If I try to pound this flat, it would actually fracture in a bunch of little pieces, kind of like what sulfur would do. So silicon is a metalloid. It looks like a metal, kind of sort of conducts electricity like metals, but doesn't have the same properties. So it's in between metals and non-metals. We call those metalloids. So again, folks, just an introduction of the elements of the periodic table to lay this out for you, and hopefully I'll get a couple other videos to explain this to you as well. So enjoy your rainy day, and I'll talk to you later.